everyone! Welcome to our Scientastic class. I'm teacher Bridgeline, and I am here to help you understand how science works in everyday life. Are you ready to join me for today's lesson? Come on, let's learn together! In your previous lesson, you studied that Ohm's law explains the relationship between current, voltage, and resistance. In symbols, Ohm's law can be written as V equals I times R, wherein current that passes through a conductor varies directly with voltage and inversely with a resistance. In addition, electric circuit is a closed conducting path wherein electric charges flow. This picture shows you electric circuit with its schematic diagram. I have here common electrical symbols used at home to represent electric circuits. Familiarize yourself with the different electrical symbols. We have battery, cell, conducting wire, closed switch, light bulb, resistor, open switch, voltmeter, and ammeter. I have here examples of pictures on how electric circuit works. Do you think all these examples works on the same way? Is the flow of electricity in the street light works the same on the Christmas holiday lights? Today class, we are going to learn about the two types of circuit. We have series circuit and parallel circuit. Series circuit. Series circuit, this is type of electrical circuit involves two or more bulbs connected to the same power source flowing in one direction only. As there are more bulbs connected in this type of circuit, the glow of bulbs decreases. The longer the distance of bulb from the source, the glow of the bulb also decreases. Once there is one bulb that gets busted, the remaining bulb will no longer glow. This is a diagram of a series circuit. Example, Christmas holiday lights. Another type of a circuit connection is a parallel circuit. Parallel circuit is a type of circuit that involves different paths for current flow. If there are two or more bulbs connected in parallel, the amount power source is distributed evenly to the bulbs. If one bulb gets busted, the remaining bulb will still glow. This is a diagram of a parallel circuit. Example of this is the circuit that operates in your home. Have you ever wondered what type of circuit connection is present at home? You may say it is a series, as you turn on any switch that controls a single bulb. Or you may say it is a parallel, because as you turn off an appliance, the other appliances are still in operation. But did you know that a circuit connection that is present at home is actually a combination of the two, the series and the parallel connection? Imagine if all the electrical wirings in your home is controlled by one switch. What do you think will happen if one of the appliances malfunction? Series connection and parallel connections have advantages and disadvantages, and let's find out. Again, when we say series circuit, it is a type of circuit that has two or more loads but current flows through a single conducting loop. Advantages of series connection. 1. It will not overheat easily. 2. It is easy to conduct repairs because all the designs can understand quickly. 3. We can put up more devices because they have higher voltage. Number 4, it is easier to find an open fault. Here are the list of disadvantages of a series connection. If one is terminated, it will affect the other circuit. It is not practical to use at home. If there is an open circuit, it will shut down automatically. While parallel circuit, it is a type of circuit that has more than one path for current to flow. The following are the advantages of a parallel connection. 1. It gets equal amount of voltage which is connected to this. 2. It will not affect the other elements once we connect or disconnect it. 3. If any circuit failed to function, the current will still able to pass through the other paths. And number 4, all the loads can operate independently. Disadvantages: it needs lot of wires, and it has the same voltage in a circuit. Table 1 shows you series and parallel circuit in terms of current, voltage, and resistance. The current in series flows through each load is the same, while in parallel, the current that flows through the circuit is equal to the sum of the current in individual load. The voltage in series is equal to the sum of each load, while in parallel, the voltage is the same anywhere in the circuit. The resistance in the series increases as you increase the load, while the resistance in the parallel decreases as you increase the load. The following are the safety devices used at home to avoid hazard and fire. A circuit breaker prevents a circuit from overloading. It works by continuously measuring the current in a circuit and prevents short circuit. A fuse. Just like a circuit breaker, it is used to prevent a household circuit from overloading. Fuses are inside an insulated casing, usually rubber, to prevent the melted fuse becoming a hazard. An earth wire. An earth wire is fitted in order to protect people from an electric shock from electrical appliances. It is a good conductor and connects the neutral wire in the fuse box and the individual power outlet in the house to the earth. The current traveling down the earth wire also simultaneously sets off the fuse or circuit breaker, stopping the current. Double insulation. Double insulation is another means of protecting people from the current that flows through an appliance. All the electrical wiring in a house is insulated by a layer of rubber or plastic so that the bare wire is not exposed. Residual current device or RCD. RCD is used to prevent household circuits leaking current. It is also called a safety switch and must be installed in any new buildings as standard fuse box equipment. This is all for today, class. See you on our next episode. Bye!